Let's suppose we've got a curve with the equation y equals f of x, and we know there's a stationary point at x equals a. So let's do a Taylor expansion about the point x equals a. So we've got f of x is approximately equal to f of a plus f dashed a times by x minus a plus a half f double dashed of a times by x minus a squared. Now let's suppose that the second derivative, f double dashed of a, is not equal to 0. And we know that f dashed of a equals to 0 because that's our definition of a stationary point. So that means that f of x now is approximately equal to f of a. Now the next term is 0, so we've just got left plus a half f double dashed of a times by x minus a squared. Rearranging, we've got f of x minus f of a is approximately equal to a half f double dashed of a times by x minus a squared. Now, because x minus a squared is a square number, it's always greater than 0. And if we have a look over this side here, f of x minus f of a, now if we've got the case where f of x is greater than f of a, our curve must look like this, where x equals a is at the bottom. And that means that x equals a must be a minimum point. And if f of x is greater than f of a, then f of x minus f of a is greater than 0. So that means that f double dashed of a must also be greater than 0. So that means when the second derivative at a is positive, we've got a minimum value. Now, the other case would be where f of x is less than f of a. So that means our curve would look something like this, where the top point is at x equals a. And in that case, f of x minus f of a must be less than 0, which also means that f double dashed of a is less than 0. So when that's the case, we've got a maximum point at x equals a. Now I've written out the expansion again with an extra term, with the fourth term, and this time we're going to suppose that we've got the case where f double dashed of a is equal to 0, which is also the case for f of a is equal to, or rather equal to, let's change that to an equal to 0, and f dashed of a is also equal to 0 because it's a stationary point. Now, because the second term and the third term are both equal to 0, we can rewrite f of x as approximately equal to f of a plus 1 over 6 f triple dashed of a x minus a cubed. Now rearranging that, we get f of x minus f of a is approximately equal to 1 over 6 f triple dashed of a times by x minus a cubed. Now in this case, x minus a to the power 3 can be positive or negative. So when x is greater than a, we've got x minus a is a positive number, but when x is less than a, then x minus a will be a negative number. And because f triple dashed a is a fixed number, is either positive or negative, but we're going to assume that it's not equal to 0, then that means that f of x minus f of a will also change sign. So when x minus a is positive, then f of x minus f of a will be positive, and when x is less than a, or x minus a is negative, then f of x minus f of a will be negative. And that'll change if f triple dashed a is negative. So we've either got the case where the curve looks like this, or the curve will look like this. And that gives us a point of inflection.